Stan Jabalisco here with Quadratic Equations, Take 3. Earlier in the previous video I talked about a brute force method, cutting to the chase in order to solve a general quadratic equation or any quadratic equation. Rather than go through the maneuvers of having to factor it and spending all this time digging a ditch with teaspoons, you can take what is called the quadratic formula. The quadratic formula, and solve this equation by digging a ditch with a backhoe instead. ax squared plus bx plus c equals 0. Now remember, a, b, and c are real numbers. That means numbers like 3, the square root of 7, let's just say the exponential constant e, or even 0, negative 4, negative 63 divided by 5. Any of those are real numbers as opposed to imaginary or complex numbers. If you are interested in imaginary or complex numbers, however, I recommend that you go back to my main channel and look for the playlist entitled Complex Number Primer. And you will learn all about them if you're willing to take the time and if you have the curiosity or the predisposition. But you can use something called the quadratic formula in order to solve for an equation like this. And the way to do that is to simply, well, as I said before, cut to the chase. X equals negative b plus or minus the square root of the quantity b squared minus 4ac over 2a. Remember, a, b, and c are the coefficients or the constant real numbers, and x is the unknown or variable which we, in our quest, shall find by plugging the coefficients into this formula. Now, the interesting thing is this quantity right here. That quantity right there is sometimes called the discriminant. That's what this is right here. That means it discriminates, or it tells you what the solutions are going to be like. If the quantity b squared minus 4ac happens to be positive, that is greater than 0, then we get a square root and we plus or minus that, and we get two real number solutions to our quadratic. If b squared minus 4ac happens to equal 0, then we plus or minus 0, we get nothing, and our solution is simply minus b over 2a. But if this quantity right here, the discriminant, is negative, we're going to get two solutions all right, but they're going to be complex numbers. The real number part will be minus b, and the imaginary number part will be the square root of some negative number under here. And then, of course, we divide by 2a, but the result of this is going to be minus b over 2a plus or minus this thing over 2a, and that's going to give us what is known as, once again, a complex number, or actually two complex number solutions. We won't go there in this series of videos because it gets a little messy. It's messy enough simply to plug these coefficients into this equation sometimes, or into this formula, and get a correct result. It's because it's pretty doggone easy to make addition and subtraction errors. I've done things like derive the formula for the surface volume of a four-dimensional sphere, but that's all abstract, and that seems to be a little easier than actually working with numbers themselves. But what this thing is called, once again, is the quadratic formula. And it is once again the brute force Gordian knot cutting backhoe that digs the ditch quick, instead of fooling around trying to factor this with all these weird and exotic techniques by digging a ditch with a teaspoon. It doesn't matter whether the teaspoon has a lot of ornate decorations on it or whether it's just a plastic teaspoon you get out of the dime store. You dig a ditch with one of those, it's really stupid in my opinion. So some people call the quadratic formula a form of cheating. I say, go ahead and use it if it works and if it saves you all that labor. And if you do use it and if it turns out that in the cosmic court it is judged as cheating, and I find out that you did it, I'll never tell anybody. Stan Gibilisco signing off. Until next time, so long.